Greetings, Patriots. In today's lesson, we're going to continue with our building houses, but now we're going to represent that situation in a graph. We want to see what that rate of change looks like in a graph. So that is our objective for today in lesson 2 of our unit 3. So one of the words that you'll constantly hear me say is constant rate of change in this unit, or your teachers. That's just remember, think about the word constant. That means something that's just consistent, that it's the same thing, okay? So it's an amount known as a rate, and it stays the same. It does not change at all when I'm comparing two quantities. I always like to think of when I go to a vending machine and I want to buy a Coke or a drink, like at Walmart, they usually cost like $1, right? Or if you want to buy some water in one of those vending machines, the rate stays the same. If I buy one soda, it's $1. If I buy two, it's $2, and it continues to increase by $1. So here's a fun fact for you. Straws. Okay, I know there's been big things in the news about straws and turtles and how they're not good for our environment. So I need you to think about this. 500 million straws are used every single day. I don't even want to know where those things end up, but think about it every day. So per day, how many straws would be used in just 2 days? We'll talk about that tomorrow. Think about it and answer the question if you know the answer. All right, so what we're going to have an opportunity to do is write about constant rate of change. So you're going to have to write your own definition. Draw me a picture, right? Where in our real life do we see constant rate of change? And then write some characteristics that you notice about it. Let's go ahead and move to the next one. What we're doing in this lesson, yesterday we looked at a table and we began to look at that constant rate of the total pieces. And we noticed that every single house that we added, it increased by 3, right? We added 3, we added 3. So what you're going to do, and then what we found out, right, is that, well, another way I could figure out the total pieces was just making a prediction, because I'm really just multiplying 3 times the house number. But now we really want to see what it looks like in a graph. So think about your x-axis. Your x-axis is going to represent your house number. Your total pieces is your y-axis. So the title that I wrote was Building Houses. Make sure you fill this out in your notebook. So remember, one house or 0 houses had 0 pieces. So I'm going to go ahead and mark that. That's one of my ordered pairs. One house had 3. 2 houses had 6 total pieces. So I'm simply just filling in my graph. 4 houses had 12, and so forth. You should see that this graph takes on a nice straight line. Think about where you're seeing that constant rate, okay? So here you go. This is what your graph should look like. I want you to answer the questions. Where is that constant rate of change in your graph? Go ahead in your notes, write that, because we're going to talk about that tomorrow. And what does the constant rate of change really represent in this situation? What does it mean as we looked at our pattern? Okay, so Patriots, did we have an opportunity to represent that situation in a graph? Yes, we did. Make sure you are able to reflect how that rate of change looks like in your graph. Have a great day.